Hello students, I welcome you in the 11th video of this D and F local element series. And before I proceed further, let's have a few lines about this ongoing chapter. The D and F block in periodic table, the middle stalk. The D and F block in the periodic table, the middle stalk. Valence electrons are kidnapped in subcells called D and F. Valence electrons occupying the lab in subcells called D and F. Iron, copper, silver, gold, the named transition elements they hold. Iron, copper, silver, gold, the named transition elements they hold. Lanthanum, cerium, uranium, thorium. Lanthanum, cerium, uranium, thorium. By inner transition names they are noun. Outside the table they are sound. By inner transition names they are noun. Outside the table they are sound. Outside the table they are sound. Now the next is ionization enthalpy. Now what is the trend in the ionization enthalpy? If we see uh, ionization enthalpy generally increases along the period. Of course there are some, I'll say, exceptional cases are there, but otherwise along the period, if we move from left to right, then ionization enthalpy values are generally increases, and it is as per their size. As size have tendency to decrease, then ionization enthalpy is tendency to increase. Now let's see some values regarding this to verify this fact. Here it is 3D series, scandium to zinc. Now there are three values of ionization enthalpies in kilojoule per mole. First ionization enthalpy when a metal is converted from M to M plus 1, and this is second ionization enthalpy when metal get converted from, that is oxidized from plus 1 to plus 2 stage, and this is the third ionization enthalpy when metal gets oxidized from 2 plus to 3 plus stage. Now you see there is a regular increase in the ionization enthalpy. Okay. Up to iron it is very smooth, but thereafter few pages, and here again a very high value in case of zinc. Okay. Now why that much high in case of zinc? Because zinc has 3d10 4s2 completely filled electronic configuration, so it is much difficult to disturb that very stable electronic configuration. Now in second and third, in third you will see the value of manganese, the third ionization enthalpy manganese is remarkably increased. You see 2393 26 23 26 28 29, and suddenly 32 3260 value. Why this is so? This is because in this condition manganese get converted from D5 to D4, that is exactly half will step is going to be disturbed. That's why it is having high value of ionization enthalpy, third ionization enthalpy. Or same case is there, very high value 3837 3837 in case of zinc, because again here you are going to disturb when Zn2 plus is converted into uh, Zn2 plus gets converted into Zn3 plus, then you are disturbing 3d10 is stable electron configuration. So change in 3d10 that demands high energy, that's why it is 3837 the highest value there. So these are the trend in the ionization enthalpy. Now let us see some more trends, some more values of these transition metals. So characteristic properties of characteristic properties of transition elements or transition metals. Okay, now in these characteristics properties uh, we will discuss about variable oxidation states, variable oxidation state, then of course we have colored ions, then we have magnetic properties, then we will discuss about catalytic properties, catalytic properties, then thereafter formation of alloys, and then thereafter formation of uh, complexes, formation of complexes, and at the last but not the least, formation of interstitial compound. Formation of interstitial compound. So these are some of the uh, factors about which we are going to discuss in these subsequent videos. So stay tuned, stay connected. Bye. Bye bye.